Now we are going to discuss about the conversion of NFA to DFA. NFA means non-deterministic finite automata, and in turn DFA means the deterministic finite automata, which we have already discussed. So when we come towards the non-deterministic finite automata, so for a single input, for a single alphabet, yes, there may be a state change. There may be a more than one state change. For example, if there is a state q0 for an input symbol a, the q0 may get into q1 and the q0 may get into q2 also. So but in case of DFA, for each and every input symbol there is a transition from one state to only a single state. That is, the transition may be resided in its own state, or else it may go to any single state. For example, if q0 is the transition is a state for an input symbol a, it may reside in q0 itself, or it may go to q1. So now we are going to discuss how to convert the non-deterministic finite automata into deterministic finite automata. So in order to perform the conversion of NFA to DFA, we are going to use the method called as subset construction method. So let us consider an example. So students, please note down it. Convert the given NFA to DFA. So this is a NFA because the Q0, from Q0 there is the Q0 responds to two inputs, that is one is 0 and another one is 1. The Q1 responds to 0, the input symbol 0. The Q1 responds to input symbol 0 as Q1 itself, that is Q1 comma 0 will be Q1 itself, and the Q1 comma 0 will get into Q2 also. So we can say it is one of the NFA. And also the Q1 comma 1 is in Q1 itself. When we come towards Q2, Q2 comma 0 will be in Q2 itself. When we come towards Q2 comma 1, again there is more than one transition, that is Q2 comma 1 is Q2 itself, or else Q2 comma 1 will get into Q1. So in order to convert the given NFA to DFA, as a first and foremost step, we have to construct the transition table. So this is what we call it as transition table. The transition table contains a state and the set of all input symbols. Here 0 and 1 are the input symbol, and Q0, Q1, Q2 are the states. For the starting state, the starting states will be indicated by this arrow mark. So arrow Q0, and the final state will be indicated by star. So Q0 comma 0 is Q0. From the diagram, from the previous diagram, we are going to construct the transition table. Q0 comma 0 is Q0, and Q0 comma 1 will be Q1. And when we come towards Q1 comma 0, for the Q1, for the input symbol 0, Q1 responds to two different states, that is Q1 itself and Q2, and Q1 comma 1 is Q1. And when we come towards Q2 comma 0, the Q2 comma 0 is Q2, and Q2 comma 1 is again there is a two transition on the input symbol 1, that is Q2 comma 1 is either Q1 or Q2 comma 1 may get into Q2. So after that we have to define the transition function. So the transition function is denoted by del. So del d means that the transition function for the particular DFA. So as a first and foremost step, del d, the transition function del d is applied to the starting state q0. Del d of q0 comma 0 is equal to q0. So in order to differentiate the NFA state and the DFA state, we are going to apply this square bracket. So after that, the same del d, that is the transition function del, has to be, we have to apply the transition function del for the input symbol q0, for the state q0 and for the input symbol 1. Now del d of q0 comma 1 will result in q1. So now we have to apply this transition function for q1, because here after the completion of q0 there is a state called as q1. So now when we apply del d of q1 comma 0, the del d of q1 comma 0 is q1 and q2. So now q1 and q2 will be combined as a single state, that is indicated by this square bracket. So this is what new state. Whenever there is a new state, we have to apply the transition function for the new state, each and every new state generated. Now del d of q1 comma 1, del d of q1 comma 1 is q1 itself. After that we have to apply del d of q2 comma 0, the q2 comma 0 will be q2 itself, and del d of q2 comma 1 will be again q1 q2. Now we have to apply the transition function del d for the new state q1 q2. This is what the transition function of q1 q2 comma 0. The q1 q2 can be separated as del of q1 comma 0 union del of q2 comma 0. The del of q1 comma 0 is q1 q2 and del of q2 comma 0, the del of q2 comma 0 is q2. So q1 q2 union q2. When we combine this, the resultant will be q1 q2. It is the same state, it's not a new state. Now we have to apply the transition function del for the state q1 q2 on the input symbol 1. So del d of q1 comma q2 of 1 will result in del of q1 comma 1 union del of q2 comma 1. So again when we make union on this, so del of q1 comma 1 is q1 and del of q2 comma 1 is q1 q2. So when we make a union for these states, then the result will be q1 q2. So the q1 q2 is combined as a single new state itself. Students, have a look on this. after transition function we have to create a transition table. So the transition table will be like this, that is q naught comma 0 will be q naught. From the previous transition function value we are going to construct the transition table as this: q naught comma 0 will be q naught, q naught comma 1 will be q1, q1 comma 0 will be q1 q2, q1 comma 1 will be q1, and when we come towards q2, q2 comma 0 is q2, q2 comma 1 is q1 q2. Now for the new state generator, the new state generated is q1 q2. For q1 q2 we have to apply 0 comma 1. So we have already applied the transition function for the new state q1 comma q2 of 0. The resultant will be q1 q2, and similarly when we apply the transition function for q1 q2 of 1, the result will be q1 q2. Now when we conclude the final states, so in the NFA the final state is q2. So whenever the new state contains q2, the new states which are all containing that final state q2 will also be considered as final state. So here the q2 is final state, the new state generated is q1 q2. In q1 q2 the q2 is there, so we have to consider q1 q2 is also as final state. I repeat, this is what given here: the state q1 q2 will be considered as final state as because it contains the final state q2. So now we have to construct the transition diagram from the above transition, from the previous transition table. So q naught comma 0 is q naught, q1 comma 1 is q1, q naught comma 1 is q1, and when we come towards q1 comma 0, the result will be q1 q2. That q1 q2 has to be considered as a new state. So now the q1 comma 0 will go to q1 q2. After that, similarly from q1 q2, q1 q2 comma 0 will be q1 q2, and similarly q1 q2 comma 1 will also be q1 q2. When we come towards q2, q2 comma 0 is q2 and q2 comma 1 is q1 q2. When we see this diagram, the state q2 is one of the not reachable state, because from q2 there is a transition, but for the state q2 there is no more transition. That is, there is no more transition from either q0 or q1 or q1 q2 to q2. There is no more transition to q2, but there is a transition from q2. So the state q2 can be eliminated because the q2 is one of the unreachable state. So when you are constructing this transition diagram, here the starting state, the indication for starting state is missing, so you have to draw the arrow here. So as this diagram, as this transition diagram, so you have to indicate the q0 as a starting state by drawing this arrow. This arrow is missing in the final slide. Please students, please make a note of it. Yes students. students, have a look on this problem once again. So we have to convert the given NFA to DFA. So you will be given either the transition diagram like this, or else you may be given a transition table of NFA. From the transition table or from the transition diagram, you have to convert the given NFA to DFA. So if you are having the transition diagram, so from the transition diagram you have to construct the transition table as like this. This is what the first step you have to do. So after constructing the transition table from the transition diagram, it is necessary to apply the transition function. The transition function is indicated as del. So we have to apply the transition function del on each and every state. If there is any new state generated, then we have to apply the transition function for each and every new state and for the each and every input symbol. So as a first and foremost, we have to apply the transition function del on the starting state q0. Del of q0 comma 0 will be q0, and we have to apply del of q0 comma 1, it will be q1. So now the resultant will be q1. Now we have to apply del d of q1 comma 0, so it will give you the new state, that is q1 q2. Now for q1 q2 we have to apply 0 comma 1. So before that we have to apply the transition function del d on q1 comma 1, it will be resulted as q1, and when we apply del d of q2 comma 0, it will be q2, and del d of q2 comma 1 will be q1 q2. After that, for the new state q1 q2, we have to apply the transition function del. So now the del of q1 q2 comma 0 will be segregated as del of q1 comma 0 union del of q2 comma 0. So when we apply the transition function, the resultant will be q1 q2 union q2, so that it will be considered as q1 q2, and then del d of q1 q2 of 1 will result as del of q1 comma 1 union del of q2 comma 1. So again we will get q1 union q1 q2, the result will be q1 q2. So it will be considered as q1 q2. The q1 q2 will be considered as a single new state. The q1 q2 is not a separate state. The q1 q2 will be a single state. For example, q3 or q4 or q5, like this. Here the single new state is named as q1 q2. We have to consider q1 q2 as a single state, then only it will become a DFA. So from the resultant we have to construct the transition table of new DFA. So it will be like this. So here the new state q1 q2 contains the q2, that is the q2 is already declared as a final state, so that we have to consider q1 q2 also as final state. So from the transition table we have to construct the transition diagram as like this. Here the q2 is not reachable state, because there is no more transition from any state, that is from the starting state. From the starting state it is not possible to reach the new, that is the state q2, so that the q2 can also be eliminated. Now let us get into the second question. Here, convert the given NFA to DFA with the help of subset construction method. Here the transition table is given to you. From the transition table of NFA, we have to construct the DFA. So P comma 0, the transition for the state P on the input symbol 0 is P and Q. So that since there is a transition for a particular state for a given input symbol, there is more than one transition, so that we can say the given transition table belongs to NFA itself. Now P comma 1 is P and Q comma 0 is there is no more transition from Q comma 0. But in case of DFA, for each and every state, the each and every state has to respond for each and every input symbol. If it is a DFA, Q0 comma 0 should have the transition to some state, but it is a NFA, so that for the state Q comma 0 there is no more transition. Q1 comma 1 is R and R comma 0 is P comma R and R comma 1 is Q. Here the R is given as final state and P is given as starting state. By the arrow mark we can say P as a starting state, and by the indication of star we can say R as a final state. So now we have to apply the transition function del on the starting state P. Del D of P comma 0 is PQ. So now PQ will be considered as new state. Now del D of P comma 1 is P itself. Now for the new state PQ, we have to apply the transition function del D for the input symbol 0. So del D of PQ comma 0 will be PQ. That is, we have to say del D of PQ comma 0 will be rewritten as del of P comma 0 union del of Q comma 0. After that, the resultant value has to be operated under the set operation union, and the resultant state will be P comma Q. Now P comma Q has to be considered as single state. Now we have to apply the transition function del D on PQ for the input symbol 1. So now we are getting one more new state, that is PR. So now we have to apply the transition function on the new state PR for the input symbol 0. So del D of PR comma 0 will be resulted again as a new state, that is P comma Q comma R. Now we have to apply the transition function del D on the state PR comma 1. The resultant will be PQ. It is already, the state PQ is already generated, and for PQ the transition function is also already generated. Now the new state PQR. Now we have to apply the transition function del D on the new state PQR for the input symbol 0 and 1 respectively. So del D of P comma Q comma R of 0 will be considered as del of P comma 0 union del of Q comma 0 union del of R comma 0, which is resulted as PQR. Again del D of PQR comma 1 will be considered as del of p comma 1 union del of q comma 1 union del of r comma 1. The result will be P, Q and R. Now from the transition we have to construct the transition table for the new DFA. So P comma 0 and P comma 1, similarly PQ comma 0 and PQ comma 1, PR comma 0, PR comma 1 and PQR comma 0, PQR comma 1 will be considered, as R is considered as a final state. So PR contains the final state R, so PR will also be considered as final state, and PQR also contains the final state R, so the PQR will also be considered as final state. So here we didn't bother about the single final state R, because in the previous problem itself the Q2 comma 0 and Q2 comma 1 becomes the not reachable state. Similarly here also the R comma 0 and R comma 1 will be a not reachable state, because from the starting state P, the P comma 0 will get into PQ and P comma 1 will get into P. After that we have to apply the transition function on PQ. If you apply the transition function on RQ, then it will become a not reachable states. So better first apply the transition function on the starting state for the given input symbol. After that, for each and every new state generated, you have to apply the transition function for the available input symbols. So as Q and R are not reachable one, in the transition table also we didn't consider Q and R. Students, have a look on this slide for a minute. This is what the transition table we have constructed from the given transition result. So after that, from the transition table we have to construct the transition diagram like this. So P comma 0 will get into new state PQ and P comma 1 will be P itself, and PQ comma 0 will be PQ and PQ comma 1 will be PR, and from PR comma 0 there is a transition to PQR and PR comma 1 will get into PQ. Similarly PQR comma 0 and 1 will get into PQR itself. Students, again I repeat, so here we have to convert the given NFA to DFA by using subset construction method. So you will be given either the transition diagram or you will be given a transition table. From the transition table or from the transition diagram of NFA, you have to construct the DFA. If you are having the transition diagram of a NFA, you have to construct the transition table first. After that, from the transition table, you have to apply the transition function, and from the transition function, we have to construct new DFA transition table, and from the new DFA transition table, we have to construct new DFA transition diagram. This is what the procedure. Here you are given a transition table directly. Here the P is the starting state and R is the final state. So this is considered as a NFA because P, 0 will get into two states, that is P and Q. Similarly, R, 0 will also get into two states, that is P and R. And also Q, 0 there is no more transition. But in case of DFA, for each and every input symbol, a particular state has to respond. So from the transition table, we have to apply the transition function on the starting state P. Del D of P, 0 will be PQ. The PQ will be a new state, and del D of P, 1 will be P itself. Now we have to apply the transition function on the new state generator. If you apply del D of Q, 0 or del D of Q, 1, you will get some state, but when you construct the transition diagram, those state will be a not reachable state as in the previous problem. So now del D of PQ, 0 will be considered as del of P, 0 union del of Q, 0, which will be resulted as PQ. Similarly, del D of PQ, 1, which will be resulted as PR. Again, the PR is one of the new state. Now we have to apply del D of PR, 0 and del D of PR, 1 like this. Now again we are getting one more new state, that is PQR. So we have to apply del D of PQR, 0 and del D of PQR, 1, which will be resulted like this. Now there is no more new state, so we will stop the process. So from the transition result, that is that from the result of the transition function, we have to construct the transition table. When we are constructing the transition table, the P will be a starting state as it is, and PR and PQR will be considered as final state, because in NFA table R is given as final state. So the states which are all containing R will also become a final state. So from the transition table, we have to construct the transition diagram like this. Here the P is the starting state, it is indicated as arrow mark, and PR and PQR are considered as final state, so which are all indicated by double circles. So students, whenever we are going to construct a NFA to DFA, the points to remember are, as a first and foremost step, if you are given a transition diagram of NFA, you have to construct the transition table. From the transition table, you have to apply the transition function for the starting state on the input symbols. If you are getting any new state, then you have to apply the transition function on each and every new state for the all possible input symbols. So after that, from the result of transition function, it is necessary to construct the transition table. When we are constructing the transition table, the final state, the states, the new states, if the new states contains any final state, then that new state is also be considered as final state. In the given example, the R is given as a final state, so the new states PR and PQR contains R, that is the final state. So PR and PQR is also be considered as a final state. After constructing the transition table, then we have to construct the transition diagram for the new DFA. So this is what the process, and this is a problem. These are all the sample problems in order to convert the given NFA to DFA.